Hello, in this video we'll be discussing the basics of water systems and supply for firefighters. This isn't going to be anything crazy, so if you've been through Fire 1, Fire 2, been doing this for a while, this won't be anything earth-shattering, but it's always nice to have a review, and if you're new to firefighting or not familiar with one water source or the other, it's just the nice, easy basics. So with that out of the way, municipal water supply. Water comes from natural sources, whether that's a lake or a stream or a river or springs underneath the ground. Wherever the water comes from, it passes through a treatment facility. That's where they add the fluoride and kill the bacteria and do whatever else they do to make it safe for us to consume. And there are three types of pressurizing the water and distributing it. Gravity systems, which are the water is in a lake on the side of a mountain above the town, and just natural water pressure alone is what feeds it through all the pipes. And there's direct pumping systems where at the water treatment plant or at the water facility they have big pumps and those pressurize the system, and when you turn the faucet on, water comes out and the pump has to work a little harder or however it's designed. And then there's combination systems. Those are the ones everyone's familiar with that most places have. That's where water gets treated at the treatment facility, it gets pumped up into water towers, and then the water towers, using water pressure, just natural, from the height difference between it and houses and the water system, is what ultimately provides the pressure to get the water to the hydrant or your house or wherever you're getting water from. Piping systems. All right. Also, normally not called water mains. Couple definitions, shortened them up as best as I can from the book. Grid describes the network of pipes that make up a water system, how they all connect. Primary feeders are the largest ones. Those are the ones you find under like a main road, or they're large and they rarely have fire hydrants. Usually these might be higher pressure coming off, the water treatment facility or the big pump leading to the water towers, that sort of thing. Secondary feeders, these are more under what you would find hydrants attached to. That's where it's running under your street, or just when a water main breaks in the winter, for those that get freezing cold temperature, that's usually what it is. And distributors, those serve individual hydrants and customers. So one of those will come off the secondary feeder and run to a factory or a business or house, that kind of thing. That's how the water that's the last stop on the way to the building or wherever it's going, pretty much. Whole bunch of names. And all these do are shut off or allow water into the system or prevent it from going places or controlling where the water goes. Now, all these couple of the first ones, the gate valve, butterfly valve, post indicator, and outside stem and yoke, we'll go over those on the next slide because I have pictures of them and it's easier to kind of show them and explain them than it is just to sit here and try to put words to something. And then for pressure reducing, pressure sustaining, and pressure relief valves, pretty self-explanatory. They're valves that either reduce the pressure going past it, kind of try and maintain the pressure as it's going past the valve, and valves that try and, or relief valves, sorry, that try to basically function as a safety feature, where if a big overpressure of water comes through, they'll bleed off that pressure and then close again, and it keeps it at a safe, normal level. then backflow preventing, which keeps water from, once they enter a building or a particular system, from flowing backwards into the main system and bringing contaminants or just wreaking havoc on the system. Alright, so up here with my mouse, this guy right here is a gate valve. And if you can see, right inside, that's the gate. Rises up and down, you turn the wheel, one wheel will be open, one wheel will be closed. And fairly simple. That's the kind of thing like little like 2.5-inch gate valves you put on a fire hydrant. That's all that is, just a really big version of that. Down below it, we have outside stem and yokes. Work fairly similar to these, big wheel on top, valve in the center down here, just like that one. The only difference is the stem on this one is in here. When you turn the wheel, nothing visible from the outside changes. With these, when you open the valve, the threaded rod that the valve is connected to spins out, and when you close the valve, this spins in. So, easy way to tell if one's open or closed is if you see a whole bunch of stem sticking out, it's open, and if you only see a little bit or none at all, it's probably closed. I say probably because it is not unheard of, especially with fire sprinkler systems, for a business owner to come in or move in or down the road, years pass, see this and go, well, that's kind of sticking up, that's in the way, or they might be coming out at a weird angle and people might be tripping over them or banging into them, and there's been times where these have been cut off and then you can't close the valve because there's only enough thread to close the valve a quarter turn kind of thing. So always something to be aware of. I've never ran into it, but just because I haven't seen it doesn't mean it can't happen. Down here, we got our butterfly valve. Usually, in fact, pretty much standard, the way these work is, unlike these two that we just talked about, where the little plate that controls the water flow moves up and down, and that's what controls the flow of water. This guy, it's more of a left to right thing. So obviously this one's closed. Pinch the handle, open the lock, and you turn it. And then this will then be parallel with the water line. And as a result, water flows through. Easy way to tell if this is open or shut is when the handle is perpendicular to the water line, it's closed, and when it's parallel, it's open. And up here we have the post indicator valve. All this is a handle and a little window. And in the window it'll say open or shut. That's all it is. Two position, open, shut, short, sweet, to the point. Some quick basics on fire hydrants. Supposed to be recommended to be spaced only no more than 300 feet apart. Sometimes they're farther, sometimes they're less. That's kind of the book, perfect world, 300 feet. It's preferred that they're located at every other intersection. So every house on any particular block, no matter where it is on the block, is within 1 block of a fire hydrant. More hydrants per that distance may be needed if it's a particularly fire heavy area, a big factory where they're doing a lot of flammable materials work or anything. Just because the recommended is 300 doesn't mean you can't put more if you want more. Additional factors for placing fire hydrants are water pressure, that kind of thing. Dead end versus circulating hydrants. This is important more so when you go through driver operator course, start pumping water, start actually running the truck. Basically, a circulating hydrant is a hydrant that is in the middle of a circuit of water mains. So water is coming from the left and up. In theory, my hydrant's right here. Water can come up from this direction and into the hydrant, or it can come from this direction and into the hydrant. So you're getting flow from two directions, which provides your best amount of water, the most amount of water you're going to get out of that hydrant. A dead-end hydrant is exactly what it sounds like. It's at the end of a dead-end street, the edge of town, that kind of thing, where hydrant's up here. You get water from this direction and up, and that's all you get. So it's getting, in theory, half as much water as a hydrant that's getting fed from both directions. Not something the average tail gunner in the back is going to worry about, but down the road, important and always nice to know. Fire hydrant failures. Hydrants, while they're reliable, do, like anything else, have problems. That can come from sediment in the water lines. Everyone's seen it. The videos out there where they open a hydrant and it looks like hot chocolate comes running out because of all the grit and grime and rust and stuff in the water. Garbage getting put in there. Bottles, bags, that kind of thing. People opening caps and shoving stuff in there because why not, kind of thing. The nut on top, especially for dry hydrants, can get frozen shut or rusted shut. So you go to open it, put your hydrant wrench on, and you're reefing on it, you're cranking on it. It's stuck. Or you can have the opposite, where the stem in the hydrant gets stripped, and you can sit there and spin it all day long, and it won't open or shut. It is what it is, and the thread is stripped. Hydrant markings. Now, all these are according to NFPA. So your light blue is 1,500 or more gallons per minute. Green is 1,000 to just under that 1,500 per minute. Orange is 500 to just under 1,000. And red is up to 500. And easy way to remember it is just each one is a step of 500 to the next. That's the kind of thing you'll see on a Fire 1 test, such as how many gallons per minute can you get out of a green hydrant, that kind of thing. That's the kind of stuff that would show up on a state test. And then black. Black isn't an official NFPA hydrant color, but from what I can tell, most places, when a hydrant is out of service or dead or otherwise, they don't use it. It usually gets painted black, or they have a big circular disc that goes on the inlet that just says hydrant out of service or non-operational or something. And the reason I specifically pointed out this color coding is according to NFPA is because NFPA is kind of a guideline. Places will paint hydrants all orange, no matter what color or how many GPMs they flow out. They'll paint them silver because that's the color that they decide to paint their hydrants. It's always nice to know roughly what your gallons per minute are. I know some places, when they do the paint them all one color, they'll have a book that'll say hydrants along this road are all 1,000 gallons per minute. They flow test them every year. They get the numbers, so there's ways to find out. But this is nice, but some places do it, some places don't. It's city preference, department preference. It's whatever it is. Hydrant inspection. Now, at least around where I live, the fire department really doesn't go out and inspect and test hydrants. That's the city water department, because they manage the water system. If we use one and something's wrong, we'll contact them and let them handle it. They're more well-versed in the water supply system than we are. But some stuff to look out for. Obstructions, Snowbanks in the winter, really big trees growing around it. Someone put a flagpole that's concrete into the ground right here, and you can't get the cap off, that kind of thing. Missing parts, within reason. A lot of them might be missing a chain. It's not earth shattering. But missing caps, missing nuts to open the hydrant, that kind of thing. That's more important. Difficult operation. Like I said earlier, you put your wrench on it, and you have two people pulling on the hydrant wrench, and it's just frozen shut, or the thread is stripped out, and you sit there and spin it all day long, and it doesn't open or close. And then evidence of leaks: soft ground, spongy ground, water bubbling up around it, a really big depression around it, that kind of thing. Evidence that there's water leaking underground from the hydrant. And rural water supply. Basic components are a fill site, tenders, portable water tanks, and then two other things we'll talk about a little bit later are relay pumping and water offloading. Fill sites. Fill sites can be anything in the rural world. Creeks, ponds, dry hydrants, which is the ones you see out in the country, for those that don't know, or city firefighters, where there's a big white pipe sticking out of the ground near a pond, and there's a gravel driveway. That's for an engine to pull in and connect their hard suction to, and they can pull out of the pond or the river or whatever that pipe is connected to. Other fill sites I've seen, a lot of rural stations will have a pond, or if they're lucky and they're in a little village with municipal water, a little wall hydrant in their station, so a fill site can be in a station, wherever you can get enough water, reasonably close to the scene kind of thing. You don't want to have to drive 15 miles to go get water for your call. Tenders. That's these guys right here. Now, I can hear you saying it, some of you. We call that a tanker. Yes. Where I live, these are called tankers too. Tanker and tender are usually used kind of interchangeably. The old people call it a tanker. The new by the book people will call it a tender. We're trying to teach good habits here on this channel, keep everyone on the same page. This is a tender. It carries water to a fire in the middle of nowhere. A tanker is the big plane with wings that drops a whole lot of water on a wildland fire. That's the difference. Portable tanks. I've seen little ones, I've seen big ones. The ones I'm familiar with are like this style with the frame. A few departments I know that are going to more of like an inflatable kiddie pool kind of thing. They're usually orange. And like I said, it's just like your inflatable pool where you put air into the little ring and then the water level kind of fills the tank and lowers with the tank and that kind of thing. And usually those are designed so you can fill the ring with an SCBA cylinder. Then relay pumping. I'm actually going to get into that, I believe, in another slide, so we'll hold off on that. And then water offloading, and by extension, water shuttles. Obviously, if we got a real big fire, I've seen tenders backed up down the road and staged in the driveway, and one on either side of a tank dumping water. Come back here. One on either side of a tank dumping water. When you're flowing a lot of water, there's a lot of trucks running around. So it's always nice to have, a guy. Volunteer department's the old guy that really can't pack up and do work anymore, go interior, that kind of thing. Water supply, especially the porta tank. Making sure people don't back into it, running dump valves, keeping everything flowing nice and easy. That's a good job for those guys. And then when trucks are going to get water, I've heard I've had instructors and people on departments say trucks should always run clockwise to the fill site and then back to the scene, or should always run counterclockwise to the scene and back. Well, it's all well and good, but what if you're on a dead end road? What if it just doesn't work? I mean, and what is clockwise? What is counterclockwise? Do they go right out of the driveway or left out of the driveway? Like, what is context for clockwise, counterclockwise? Basically, at the end of the day, the best idea is to keep all the trucks running in a big circle in one direction, from the scene to the site and from the site to the scene. Because nothing good can come from tenders running emergent, running towards each other that often. Sometimes you have to, but it's always nice just to kind of keep the flow of things going in one big circle. That way, when they get to the scene, they're all parked on the same side of the road. They're not trying to fight each other to leave, that kind of thing. There we are, relay pumping. The water supply through relay pumping has to meet the demands of the fire. Sounds obvious, but sometimes you get those relay pumping operations, and I've been on them, where things are done not by the textbook, but real world is very rarely done to the textbook. But I have seen them where you're relay pumping and the relay engine is maxed out, and the fire tack engine's calling for more water, and the relay engine can't give any more water. Few pointers on making this maybe not perfect, because kind of hard in the real world to be perfect, but some points to consider. The relay pumping operation must be reasonably quick to set up. Yes, it takes time to position trucks and dump LDH and set up, a porter tank on the road to relay down the long driveway to whatever's on fire. But it has to at least be quick enough to be worth the effort. If it's quicker to just drive a tender down to the building that's on fire or the fire attack engine, offload into a porter tank at the engine, and then leave, and everything works out that way, go for it. Every situation is different. Pick the best situation for the best scenario, kind of thing. Trucks needed and spacing. Spacing varies by department. I know about 500 feet of LDH is kind of the max around where I am. One of those, if you're going uphill, you may need more trucks per distance. If you're going downhill, you may be able to get away with fewer trucks for a longer distance. Basically, you need enough trucks to maintain pressure and keep things moving efficiently and with enough volume. Size of supply hose. Minimum 2.5 inch hoses. But with friction loss, that really isn't a lot when compared to a single LDH 6 inch or 5 inch kind of thing. And when you're trying to lay 2.5s, if you're doing a 500 yard relay times 2, that's 1,000 yards of LDH, or 1,000 yards of 2.5 you're going to need. It's a lot of 2.5. Distance to cover, I already kind of covered that. Longer distance, more trucks. And then truck capabilities. One thing to at least try to do. Again, real world, what are you going to do? But always try to have the truck with the largest pump, the largest gallons per minute capable, the first in your relay pumping line. So, for example, if I have one of those really sweet big engines that can do 2,000 gallons per minute, I'll put that first in the line. And then I'll do the truck with 1,500, and then the truck with 1,000, and then the old beaten up truck with 500 at the end. Because If you were to do it the opposite way, you're limiting what you can give to those other engines. So instead of being able to supply, 1,000 gallons per minute up until the very last little push, you're limiting all these big engines with all these big pumps to 500 if you put the little guy first in line. Just one of those. Try and stack your pumps accordingly. Here, try to keep that short, sweet, to the point. Didn't cover anything earth-shattering, but so far just trying to cover, the book basics, the stuff that you see a lecture on in class or at the academy, and you may have a quiz on it, and then 6 months down the road you're trying to remember all that you learned, and you just want a quick refresher, that kind of thing. So, thank you for watching. If there's anything you want to see, let me know in the comments.